Welcome back to STEM Online Academy. My name is Jason Masterakos. Right? I am the president and founder of STEM Online. Okay, so let's get right to it. I won't go into my background for new viewers. You'll figure out as the video progresses. All right. So if your first move in a hard a calculus-based problem, is to start calculating, you are already in major danger. Okay. Yes, you're already in danger. Right? Just because the title of the subject is called calculus doesn't mean you're calculating stuff. Not even close. Unless you're doing high school math, then it more likely is. But otherwise, no, that's not the real definition of calculus. So what we're going to do, the usual, right? I'm going to come up with some thought-provoking questions that I think we should discuss, which is very important when it comes to mathematics, calculus, but mathematics in general, though. So let's get right to it, right? And also, there's going to be a video to keep you entertained, all right? So I want you to look at this video that way, all right? So as you can see in this video, right? There's going to be a bunch of things, a bunch of questions will be answered based off what I have here, right? So question number one: what's your mind do before your pencil moves? Yes. And I think a lot of you can relate to what I am saying. Okay? At least, and a lot of you don't understand what I'm saying because you probably haven't had experience. But for those of you who have had experience with problem solving, you know what I mean, right? What do you do if with your mind, before your pencil actually moves on the paper? Okay? So that's question number one, right? Now, looking at looking at question number two, what information is the problem hiding in general? Right? Quite often, problems hide very useful, very valuable information, but we have to be able to decode it. We have to uh, be able to decipher what is being asked, and it's not always easy to decipher what's going on in the problem. Okay, so yes, that's question two. Question three is, what are the words that reveal, okay, that reveal the mathematical structure? Usually there's some keywords, especially if you're doing anything to do with problem solving, okay, or problem solving or application questions or geometric questions. And usually there is some keywords there that need to be addressed when you're solving any type of mathematical problem, not just calculus. Okay. Question four: how do you predict the shape of the answer, right, before computing? So how do you predict the shape? What I mean by that is some type of intuition. Okay, that's what question four is. A lot of you probably don't know, and then some of you do know, most people don't, that mathematics requires a sixth sense, okay? At least when you're dealing with advanced mathematics, okay? It requires a sixth sense to solve and come up with questions and solutions to problems. And it's not always easy, all right? But a sixth sense is necessary. And you can develop the sixth sense just from a lot of problem solving, okay? And finally, question five: why is verification impossible if you don't create a model? Okay. Why is verification impossible? So let's get to question number one, which I think is very important. Okay. Question one, we're going to answer it. Well, I actually want you to think about it a bit before I jump into details. Okay. So what what should your mind do before your pencil moves on the paper? Okay. So what should your mind do? So don't just right away write down the algebra really fast or whatever. Take a moment to think. Okay. and we also do this in other things too, not just math, but you need to be able to step back and think for a minute, right? Depending how long it takes for you to think, hopefully it's faster. But take a moment to think and sort of think ahead is what I'm trying to say here. Okay, you need to think multiple moves ahead when you're dealing with a hard calculus problem. Okay, or calculus-based physics problem, right? Or anything of that nature. Any subject that requires hardcore problem solving. Okay, you need to think a few steps ahead in order before you can actually start writing down the algebra. The algebra, you have to understand, yes, algebra can sometimes be hard, even if you have a algorithmic technique. Algebra can still be hard. But what's even harder is if you don't have a direction for the algebra. Okay, you have to set up a model. You have to have a strategy first. Otherwise, the algebra won't give you the right answer, especially when it comes to optimization problems. I know it's just the most optimization, uh, related rate problems, these types of problems, or calculus-based physics problems, because they're application problems, require you to set up a model. If you don't have the model, it's just going the algebra will turn to nonsense. Okay, so take my word for it. It's very, very, very important. Okay, this is no bullshit. Okay. All right. So that's the answer for question one. Now, question two, what information is the problem hiding? Okay. Now, there's no general formula for this. Okay. I can't give you a one thing solve all solution, right? However, though, uh, there are general patterns that we can detect. Okay. When it comes to what information is the problem hiding. Now, you have to look, it's a mixture of a language, right? A mixture of language and a mixture of some type of intuition. Okay. There's certain things that you will notice in the problem that you have to decode. Okay. Decode what is being said, decode certain keywords, decode you may have to decode the equation. Sometimes it's not a word problem. A lot of times in math, it's not a word problem. You have a equation, right? Standard equation of some sort, and you have to solve it. But you can only solve it if it's in a standard form of some sort. Otherwise, you can't use a mathematical method or a mathematical technique. Okay, so the way to do it, right, is to either manipulate that equation if you're dealing with equation, manipulate the equation such that it's in a mathematical form that you can then apply techniques, definitions, formulas, and whatever. Okay, you have to put it into a correct form. If not, you'll be stuck. Right? So depending if it's a word problem or just some, abstract equation, you have to be able to figure out what is hiding in that problem. Okay. Question three. Okay. All right. So question three now. What was it? I have my list over here. I'm just reading. Yes. What are the words that reveal the mathematical structure? So this is just, I'm talking about keywords. You need to look for keywords. There's no formula for finding the exact keyword for every single problem in every situation. That is up to you to understand and figure out what are the keywords in that specific problem that helps to decrypt the mathematical structure. Right? Well, I mean structure. I mean in terms of symmetry, geometry, or stuff like that. Okay. All right. So you have to be able to decrypt it. Okay. You have to be able to figure out what are the words that reveal the structure. Okay. Um, for instance, maybe you have a problem, right? And it says you're given a triangle, okay, and given some base B, some perpendicular bisector height, some slant height of S, as some what other information it is. By the way, I'm just taking this from the top of my head. I haven't thought of the question through, so I may be missing some stuff. So uh, sorry about that. Just let me know. Uh, and let's say the question is find the maximum area of this isosceles triangle. Okay, so the maximum area of the isosceles triangle, right? So you have to look for certain keywords that will reveal what you need to do about the problem. Area and maximum are the keywords here. Why? Because we know that there is a theorem or theorem or definition when it comes to maximas and minimas, concave ups, concave downs, and stuff like that. Okay, so we can relate to that theory. See what I mean? You have to relate the words, and sometimes it's even trickier than that. Words to known definitions, theorems, and formulas. Good. So that's what I mean by question 3. Now, question 4, right? How do you predict the shape of the answer before computing? Now, this I want you to think about. What do I mean by that? Predict the shape of the answer before you actually calculate it. Well, I don't mean the actual shape, I mean the strategy, right? What is known, what is unknown? Well, before knowing what's known and unknown, you need to be able to extrapolate, either visualize, and visualization can mean many things. Maybe if it's a geometric problem, you need to draw it, so that's where you see what is happening. Okay, if it's an equation, you may not be able to draw it if it's very abstract, or you don't have the algebraic or graphical tools to, because the problem is tricky. Can't always do it. Quite often, I do recommend if you can graph it. Graphing is very handy. But if you can't graph the function, and yeah, if you can't graph the function, at least visualize the problem. Like take the equation and translate it into words if possible. For instance, maybe it's a crazy integral. You know, if it's an integral, it has to do with accumulation. Okay, think of accumulation. Think of areas. Think of summing up the trapezoidal shapes under the curve. Think of Riemann. Think of stuff like that. Right. So you can sort of get into the conceptual underpinnings of the problem. Okay, and that gives you more of a stronger foundation and shape of where the problem is going before you actually calculate it. You understand what I'm saying? All right. That's question 4. Now let's answer the final question. Okay, which is question 5. Question 5, though, is why is verification? I thought about this. Why is verification impossible if you what was it? If you can never created a mathematical model, why is the verification impossible? Why is verification impossible? Well, it's both possible and not impossible, right? It depends how we define impossible. Um, so verification is impossible if you don't have a model. What I mean by model, I don't mean when I mean model now, I don't mean specifically the usual model like you graph something. Okay, I'm talking about an entire strategy, an entire problem solving strategy. Okay, I don't mean geometric model. That's not what I mean. I mean a strategy that you can implement. Right. Without a strategy, you can't do the verification. I mean, you can, but more likely the verification will be wrong. You'll get left hand side of the equation won't equal the right hand side, so something won't make sense. And or you'll, if it's just the regular proof, you just go nowhere. The whole thing just collapses. It doesn't make any sense. Okay. So that's what I mean by a verification. Okay. Uh, so you need to have a model, and the model is okay some sort of framework, as I said, something that you can figure out what to do. Right. Yeah. list down what you know, don't know, how I should go about the problem, how I should strategize the problem, okay, how I should, maybe I need to translate my equation into words, sometimes vice versa, but quite often, since we're dealing with symbols in math, we need to translate it into words, understand semantically what is being asked. That's not always easy. And from there, once we understand what's going on linguistically, we come up with a thing of attack, if I like to say, right? Some approach that will actually nail the problem, you know, airtightly. Okay. So those are the 5 questions I think will be very handy and that you should take away from this. All right. All right. So that is it. Um, Again, I hope you enjoyed this video. Like and subscribe, please, for new subscribers. It's always handy if you can like and subscribe, right? Because if you subscribe, you help the channel a lot. Okay, right? Subscribing is really helping us and uh, helping the entire STEM Online family succeed. So if you can like and subscribe, you guys, that'll be great. Before I get going, okay, uh, it is it's always a pleasure to have my present subscribers. I have to thank you again. Without you, it's impossible to survive. But not just that, there'll be plenty more interesting videos coming up. We're going to talk about what STEM Online can do for you, and etc. Speaking of what we can do for you, right? Because we are an online coaching company. Uh, it is back to school, right? Yes, it's back to school time. So, if you're a parent or student from grades 11 all the way to third year university, I am always here to help, right? Our approach is unique. It's not about, we have a very different approach compared to a lot of other tutoring companies. We don't help with homework. So, if you're looking for homework, that's not what we specialize in, okay? We're here to help you understand deeply and mathematically how math works. Okay, both in pure math and in applied mathematics. That's what we do. All right. So that's why, because if you understand how it works, how the subject works, the subject matter, not only will you become a much stronger thinker, but it will also uh, help you much longer than just that specific homework problem for that specific grade. It will have a long lasting effect on your life and in your school life, right? If you learn how to problem solve, okay? It's not always easy. It's not always easy. No, it's not. Sometimes it's hard to very hard. But there's much more value in that than just doing homework questions. So if you're a parent or student who's looking for long uh, long lasting results, STEM Online Academy is the place to be, right? So you'll find the link to all this information below. And yes, that is it. So stay tuned. There'll be more information coming up about our back to school, what we're going to do for back to school. And yes, that is it. Thanks again, guys. Have a beautiful day. Bye bye.